Embrace's new open-source Swift SDK is built entirely on OpenTelemetry. The Embrace instrumentation is designed for full visibility into the mobile user experience, and now our feature set maps to the OTel signals in the specification, making the information portable and standardized. It's our first giant step in defining what extensible OpenTelemetry can look like on mobile. A core feature in the new Embrace Swift SDK is performance tracing, which is built on OpenTelemetry spans and allows you to observe any operations happening in your app that you're able to instrument. In this tutorial, we'll use the Embrace Swift SDK to automatically and manually instrument iOS applications and then export OTel spans to the collector of your choice, without ever having to touch Embrace's backend. Let's get started by bringing the Embrace SDK into a simple project. Here we have an app that does one thing. It makes a network call after you press a button. Let's bring in Embrace's instrumentation to capture information about this request and then export it after. The easiest way to add Embrace to your project is using Swift Package Manager. From Xcode, go ahead and add the package dependencies by entering the URL for the open source SDK and then hitting Add Package. You'll see a few package options come up here. We recommend bringing in the Embrace IO product because this will give all the functionality of the SDK and a simple, easy to use interface. Once the package is added in Xcode, we'll want to configure Embrace as early in the app's lifecycle as possible. Here we have a Swift UI app, so we'll create an initializer on the app object itself to configure the SDK in. First, let's make sure that we import the Embrace package that we're going to use, Embrace IO. Then, within the init, we're going to create a do catch block wherein we'll try to set up the Embrace client. The setup function takes an Embrace options object whose only required argument is an app ID. You'll need this app ID if you want to connect with the Embrace backend, but since we're not doing that here, we'll instead use a dummy string. Finally, to get the Embrace SDK configured and ready, you just have to make a call to start the SDK. Now when we run the app, the Embrace SDK will start on its own to track app, user, and device activity. For example, the network requests that can be triggered with this button are captured by the SDK. So too are the sessions for the user's time in the app and with the app in the background. However, without a backend connection, we currently don't have a way to get data out of the app. Fortunately, the OpenTelemetry community is an active one and is constantly building tools to help support the growth of OpenTelemetry. This open source OpenTelemetry-Swift repository provides a number of capabilities that fit and expand the OTel specification, including the signals that are at the core of our Embrace Apple SDK. Additionally, organizations and individuals donate code that works within the OpenTelemetry community. And so from here, we can go in and grab an exporter to pull the information out of the Embrace SDK and send it to a collector anywhere else. Let's pull in the Stdout Exporter as a simple example to make sure that the networking that we have in our demo app is being properly mapped to traces. To get the exporters, we'll need to import the OTel Swift repository via Swift Package Manager. We can see on the left that OpenTelemetry-swift is already in use by the Embrace SDK, so we'll have to make sure that whatever we import is from the same exact version. If we add the package from the URL, we'll set the exact version to be 1.5.1, and then once we've loaded these, we'll add the Stdout Exporter. First, import the Stdout Exporter so we can configure the Embrace SDK to export spans to Xcode's debug console here. Then, in our setup call, Embrace.options can take an optional export argument, creating an OpenTelemetry export object that will connect the Embrace SDK to any span or log exporters sending the data elsewhere. Let's add a span exporter that is the Stdout Exporter so we can see any spans the Embrace SDK creates automatically in Xcode's debug space. Now if we run the app, we should start to see some output in Xcode's debug area. Here we see some terms that should be familiar to anyone who's engaged with OpenTelemetry. We see span kinds, traces, spans, and the like. However, it would be good to have a more robust UI than this output area here to export these signals to so that we can query and structure the spans that are being collected. Luckily, there are a few open source tracing systems available that have exporters for the Swift language. This UI is for Zipkin, which is an all-in-one collector, API, and UI for distributed tracing. I'm running this locally, and I'll connect the app to it by using a Zipkin-specific span exporter from the OTel-Swift repo. The ZipkinTraceExporter can also be gotten from the OpenTelemetry-swift package. Let's bring it in and replace the Stdout Exporter here with the Zipkin exporter. In these options, we should be able to use the default options and then be able to run our app and see the traces that were being logged in the debug before in the Zipkin UI. Back in Zipkin, we can run a query to see all the spans and traces that have come in from our button app. These were all exported by the Embrace SDK, so let's take a look at what the SDK itself is automatically capturing. Here we see a post to a URL for sessions on the right. If we go back, we'll also see there's a two-span EMB process launch trace here. Let's take a look. This trace automatically captures the total time that it takes to launch our app. If you look at the span hierarchy, you'll see that a child of the root span is this emb-sdk-start, which measures the time that the Embrace SDK itself took to launch. Then over on the right, in the tag section, are attributes that have been attached to this span, as well as information about its parent, its ID, the service that it came from. If you look at the tags, or the attributes, most of them have the EMB prefix, which indicates an attribute key that Embrace's Dash will use to process and query this data. Thus far, we've used the Embrace SDK for out-of-the-box tracing for features like networking and startup. However, it's much more likely that we'll want to instrument for common workflows in an application, or even something like a game loop. Here we have the game Simon, a pattern matching game. If you aren't familiar, each round Simon will add one button tap to the game, and so long as you keep guessing correctly, you move on to the next round. If you guess incorrectly, the game is over and you'll have to restart from round 1. Thus, a game is made up of rounds. Let's add tracing to track the rounds within a game. Here in the model behind the game, we'll see two important concepts. The concept of the game itself, the game state here, and the concept of the round, which is an individual playback moment within the game. Our goal here is to track the duration of the game, and then within the game, track the rounds that are occurring in it. Thus, we can model a game as a root span or trace with multiple round spans occurring within it, but never overlapping. Each round can end in success or failure if the user moves on to the next round or if they fail to recognize the pattern, but the game span itself only ends when a player loses. First, we're going to build a span that tracks the entire duration of the game. This span also will contain the score for the user at the end of the game. This span will start when the user taps the start button and will end when the user failed to repeat a pattern. So to get our instrumentation going, let's make sure we import embrace.io, and then I'm going to create a span object. This will be our game span. We're making it optional because each time the game is started, we're going to want to replace the value. We don't want one running for the duration of the application. So this start function is where we start a new game of Simon from the beginning. It resets the score and it creates a new first round. What we'll add here is the creation of a new span that's assigned to game span. So here we're going to interact with the Embrace client, which is the interface that we imported before. And there is a function that lets us build spans. We can give it a name. And you'll notice we're going to get some red here. Build span doesn't actually create a span. It creates a span builder object, which is a precursor to an OTel span. What we have to do in order to actually start our span at this time is called the start span function. So now the game span holds a new span in it that has begun right at this line where we started. So we've started our game. The only other case we have to deal with right now is we have to end the game at some point. As we look through here, we'll be able to see when we fail, when the game state is a fail, this is where we're going to end the game span. We'll also be able to add a score to this game span before it ends. So we can add an attribute to our game span, and we can call this player score. The attribute value is going to map from the pattern, the number of rounds that we've seen in the pattern, which is a computed property up here called round number. This attribute value is just looking for a Swift type. We're going to give it an int, and that int is going to be round number. So before the game span is ended and sent to the collector of our choice, we're going to add an attribute, or what in Zipkin will look like a tag, that says the score for that completed span. Note that for our SDK, you need to manually end all spans currently. So if a span never ends, it will not be exported. Here we can see the game spans came through. And if we look a little further in, we can see the duration, we can see more information, we can also see player score as an attribute down here. So in this 5-second game, the player only got 2 points, whereas in this 9-second game, the player got 3. So it's a pretty easy way to measure how well someone did. Let's add a little more to our tracing here by adding a trace for each round. Similarly to the game span, we're going to create a round span that tracks everything happening in a single round of the game. We're going to create a new round span every time a new round begins within a game. And so I've created the outline here of a helper function that will create a new round span every time it happens. This helper function is going to take in the round number that we're currently in so that we can track over time the player's progress. Let's build that helper function now. So our function is going to take in an int, and then it's going to return an optional span. That's for 2 reasons. First, we want our round span to be the child of the game span. So let's make sure that the game span actually exists. If it doesn't, we're not going to build a round span right now. Additionally, if you recall, the client interface for Embrace is optional unless we unwrap it. When we want to build a span, this is going to return an optional object. So let's just keep going from here. Our round span is going to be called Simon Round. We're actually going to add some attributes to it off the bat because we know what round we're beginning with. So let's add, for the key round number, we'll add a string holding our round. So here we have a span builder that hasn't yet been started. Before we start the span, we're going to want to make sure that we set the parent. So this round span is going to be the child span of our game span. We can set that by using a setParent method and making sure to indicate that the parent will be the game span. And then we can start the span. Now, we'll also need to figure out where to stop the round span and when to give feedback. Let's take a look at the select function here. When a user matches the pattern, then that means that they've succeeded in the round. The round will end, so a new round will need to be created. Before the new round is started, and before we change the game state, we'll want to indicate that our round span was completed. And then let's go ahead and end the span manually. So this is the case where the user succeeded in that round. However, let's continue and look where they failed. We already set up some end of game logic here. Let's also set up some end logic for the round span. And here we're going to say that they had an error of failure. So when the round span ends and a user lost the game, we're going to indicate in our tracing that they had a failed round. Let's see what that looks like with a little bit of gameplay. So looking for the last time at Zipkin, we see here there's gameplay for 14 seconds. It's ending with some kind of alert. Let's take a look. Within the course of our Simon game, there were 3 rounds. Each was a child of the game, and the first 2 ended successfully, but the third ended with a failure code. We're able to do a great many things with braces tracing. Most important is that we're able to export these signals to any OpenTelemetry compatible vendor or collector. We did a great deal in this tutorial with automatic implementation of traces and also with some manual tracing. In particular, the manual tracing has limitless possibilities. At any point in our game here, we could add more information to a game or a round. We could say if there was but that's beyond the scope of this tutorial.